So before we move on to the next question, friends, let us understand a simple yet effective property of equilateral triangles. Okay, so let's assume that this is an equilateral triangle ABC. In context of an equilateral triangle, one of the most important properties that is heavily tested in geometry is that if you consider AD as a perpendicular, that would also be a perpendicular bisector. It would also be an angle bisector, and it would therefore also be a median. This symmetry of the same line displaying all the properties exists only in an equilateral triangle, correct? So all the three lines displaying all the three properties, that of being an in-center, circumcenter, centroid, and orthocenter, all these 4 points would converge to to just 1 point only in case of an equilateral triangle. Okay, so this is an important property. Now, as discussed, these are perpendiculars and bisectors as well as the medians. Now, this is an incircle and this is a circumcircle. So what happens essentially is that this entire height that you notice from A to D is broken into two parts. One which constitutes AG or AO or AI, which is essentially the circumradius, capital R. And from this point on to D, you have the in radius. So this is broken into two parts. First is this and the second is this. Okay, so the ratio is 2:1. Now let us assess the question which relates with this property. Of course, from geometry. Let us make use of this property. What does the question state? An equilateral triangle is inscribed in a circle of radius 20√3, correct? The centroid of the triangle ABC is at a distance of D from the vertex A. So where is the centroid? As we said, that all 4 points would be the same, would essentially be the same points, or would be the same point. So GA is as good as saying AI, as good as saying AC, and OAO, correct? So please don't confuse this C with this vertex. This C stands for the circumcenter. Okay. So now what is expected? The centroid is at a distance of D from the vertex A. So what is D equal to? Obviously, this radius, which is the circumradius, is itself equal to the distance AG. Okay, have you noticed this? So this gives your answer, 20√3. Now, what is important to note is that if we know such properties, friends, beforehand, and we've revised them before going to the exam, it will help you fetch marks 1 and therefore get an edge over others who completely ignore chapters, and also those set of students who try to derive these things during the exam itself, which becomes rather challenging. Okay, or that becomes time consuming. So just make note of such important properties that will hold you in good stead in such situations. Okay.